So,
Good evening, sir.
good evening. So, two of you have joined. Okay, let me open my books and all, then we will start, and I'll share my screen. Okay, let me share my screen. Okay, my screen is visible, right?
Yes, sir.
So I'll continue with the same bisection method. Uh, yeah. Let me come to the book actually. Then it will be here. So if you, this is the Sastri, Numerical Methods by S.S. Sastri book. So this is a very fundamental part, like uh, uh, solution of algebraic and transcendental equations. You know. So transcendental is most of the time in science and engineering. The most frequent problem is basically to find the roots. Is basically to find the roots, uh, find the roots of the equation of the form fx is equal to 0. Fx could be quadratic, it could be uh, could be uh, uh, cubic, biquadratic, or any polynomial equation. All right, any polynomial equation it could be. Sorry. And so fx could be written as a polynomial of the form, as you can see, fnx is equal to a0x, a0xn plus a1xn minus 1. So it is written in the descending order. A0xn plus a1xn minus 1, a2xn minus 2, and up to an. Or you can also write in the opposite order, like a0 plus a1x plus a2x square plus a3x cube up to an xn. So this is basically called a polynomial equation. uh, and if it is not algebraic, this part is very much important. You can uh, a non-algebraic function is called transcendental function. A non-algebraic function is basically called a transcendental function. Non-algebraic function is basically called a transcendental function. Okay. And transcendental function means ln x, e to the power x, sin x. If those kind of functions are there, then it is called a transcendental function. All right. So how to solve? Uh, so there are few conditions, as you can see over here. Uh, Somehow my pen is not 100%. So I would suggest all of you to keep writing on your notes. I'll be highlighting in the book and I'll try to explain. So if fx is a polynomial, if fx is a polynomial of the form, which form? A0, this form. Fx is a polynomial of this form. A0xn, A1xn minus 1, A2xn minus 2, that kind of form. Huh. The following results from the theory of equations could be useful while locating the roots. What are the, so these are like observations, but every polynomial equation of nth degree has n and only n roots. So if it is a quadratic equation, it will have two roots. If it is a cubic equation, it will have three roots. It will not have four roots, or it will not have two roots. It will only have three roots. Cubic equation, three roots. Quadratic equation, two roots. Nth order polynomial, n roots. Okay. If n is odd, the polynomial equation has at least one real root whose sign is opposite to that of the last term. If n is odd, if n is odd, then the polynomial equation has at least one real root. This is very important. You know, if x square is equal to minus 1, then both the roots are imaginary, plus I and minus I, right? But if x cube is equal to 1, then it will have three roots, omega square and 1. eh? So that kind of equations. So if n is odd, a polynomial equation has at least one real root whose sign is opposite to that of the last one. If n is even and the constant term is negative, if n is even and the constant term is negative, then the equation has at least one positive root and one negative root. If the polynomial has a real coefficient, then the imaginary roots occurs in pairs. So most of the time, imaginary roots occurs in pairs, and rational coefficient, then the irrational roots occur in pairs. Okay, Descartes. This is Descartes. That's not Descartes. This is called Descartes. Descartes' rule of signs. On a polynomial equation f of x is equal to 0 cannot have more than the number of positive real roots then the number of changes of sign in the coefficient of fx. Fx, whatever sign it has, a polynomial equation f of x is equal to 0 cannot have more number of positive real roots than the number of changes of sign in the coefficient of fx. Coefficient ଗୁଡା ଅଛି କି a0 a1 a2 so ତାର sign ଉପରେ depend କରିବ କାହାର whether the roots are positive real roots ଅଛି କି ନାହିଁ. In f of x is equal to 0 cannot have more number of negative real roots than the number of changes of sign in the coefficient of f of minus x. Okay. So most important part is the first one. Every polynomial equation nth degree has n real roots. N roots, not real. And if n is even, sorry, n is odd, then at least it should have at least one real root. If n is even, then it could have real root, or it could have equal roots, or it could have imaginary roots. But if imaginary roots occur, they will occur in pairs. Okay. Or if irrational root occurs, then the irrational root will also occur in pairs. Okay. Now let us try to understand uh, this figure which I was drawing last class. So what exactly it is doing? So we have to find out this point. We have to find out this point actually, where f of x is equal to 0. And we are starting from x is equal to a and x is equal to b. X is equal to a and x is equal to b. So next, From A at f of A is not equal to 0. F of B is also not equal to 0. But we are interested in finding out the value of x where f of x is equal to 0. So what we do, we substitute, we set xr is equal to a plus b by 2. A plus b by 2. Okay, a plus b by 2. All right. So that's what I was telling. If f of a and into f of b xr is less than 0, the roots lies in the interval a and xr. If f of a into f of xr greater than 0, then the root lies in the interval xr b. If f of a into f of xr is equal to 0, it means xr is the root of the equation. So this is what we will be checking in bisection method. Okay. So I suggest all of you to work it out this problem. F of x is equal to this one. F of x is equal to f of x is equal to x cube minus x minus 1 is equal to 0. X cube minus x minus 1 is equal to 0. So what will be the value of x? What will be the value of x? समस्या करूछ ना खातारे?
Yes, sir. We are started.
Yeah. So what we will do? We'll take any two guess. So where if guess works, then that is fine. If I substitute, let's say 1, if I put x equal to 1, then it will be 1 cube minus 1 minus 1. So 1 minus 1 minus 1. That will be minus 1. So that means f of x is negative. Right? For 1, x equal to 1, f of x is negative. If I take x is equal to 2, x is equal to 2 means 2 cube minus 2 minus 1. So that will be 2 cube is 8 minus 2 minus 1, that will be 5. So that means f of 2 is positive. F of 2 is positive and f of 1 is negative. So if I try drawing, let me just try. So suppose uh, I have this kind of function where f of a is negative. So the function is somewhat like this. So this is my 1 and this is my 2. Okay. So at f of 2 it is positive, f of 2 it is positive, and f of 1 it is negative. Okay. So that means f of a into f of b is equal to f of a into f of b is less than 0, not equal to is less than 0. So in that case, what I will do, I will take the midpoint. That's what it is telling. So since f of 1 is negative and f of 2 is positive, the root lies between 1 and 2. And therefore, we take x0, which is the middle point, which is basically equal to 1 plus 2 by 2, which is basically equal to 3 by 2. Okay. Now, what is the value of f of x0? F of x0, if you substitute 3 by 2, then you will get 15 by. If you substitute in this equation, the value of x naught is equal to x0 is equal to 3 by 2. Then substitute that, you will get 27 by 8 minus 3 by 2, which is equal to 15 by 8. Okay, which is equal to 15 by 8. Okay. Now let us, but f of x naught is not equal to 0. It's not equal to 0. So we have to still find out the roots. We have to still find out the roots. So the roots lies between now 1 and 1.5. Okay. The roots now lies between 1 and 1.5. So next point will be x1. x1 will be equal to 1 plus 1.5 by 2, which is equal to 1.25. Now what we will do? We will substitute the value x1 is equal to 1.25 in value of f of x. Value of f of x, which is basically x cube minus x minus 1, x cube minus x minus 1. Okay. Now, if we substitute that, x2 will get if x1, then we'll get f of x1 is equal to minus 19 by 64, which is negative. Now we find out what is x2. X2 will be 1.25 plus 1.5. So then 1.375. If we keep on doing this, the procedure is repeated. The procedure is repeated, and the successive approximations are like this. Successive approximations are like this. Okay. So where exactly it will stop? Where exactly it will stop? When, let's say, x10 and x11 are almost equal, then only the iteration will stop. For example, if I say 1.34 and 1.32 are almost equal, it's almost like 1.3. So then I'll stop it here. But if I say no, I want to go up to third place of decimal, approximate up to third place of decimal, then I have to find out what is x6, what is x7. So depending on what, where exactly we want to, where exactly we want to stop with our approximation, then we will stop there and find the root. Okay. I would suggest all of you to work it out and tell me the answer of this one. XQ, this part, uh, XQ minus 2x minus 5 equal to 0. XQ minus 2x minus 5 is equal to 0.
You can
Can all
use
of you work?
calculator.
Yeah, yeah, yeah. You have to use calculator. Sorry?
Sir, I was asking I
Yeah,
can
you have
use
a question?
calculator.
Ask me.
I can use
Yeah, yeah,
calculator,
you can
sir,
use,
na?
you have to use
Oh,
calculator. Yeah,
okay.
yeah, you can use calculator. That is fine. Yeah. So find the root, find the solution, x cube minus 2x minus 5 equal to 0. Take 5 minutes and tell me what is the answer using this method. Okay. I give 5 minutes and work it out by bisection method and tell me what is the answer. Okay. Anyone getting answer?
Sir, I'm getting 2.046.
2.046. Let's see.
Two,
So it is telling 2.0625. If you see,
2.125 I have
if you come up to X,
after
yeah. So next one would be
the
2.0625.
up to X4 2.0125 I have got 2.0625 I have got. After that I have
Okay.
got 2.046875 in
Now,
X4.
two values you are using? Check that. Check that. Which two values you are getting? Okay. Because you have to find out what is fx4. It has not calculated here. You have to find out what is fx4.
So
Okay.
FX4
You have to find out. Yes.
putting 2.0625 we got
Yeah.
negative for the negative. So that's
Negative.
why
Okay.
again, so we have to again find between 2.2 and
Between.
between. Oh, sorry, we have to find this one. No, no, that is also positive. So we have
You
to
have to
again
find
find between
between.
2 and 2.0625 because 2 f of 2.0625 is coming positive. So 2 x2
Two
is
point
negative.
2. No, no, your x3, f of x3 is positive, right? F of
F
x3 is
of x3 is
positive.
positive.
0.
Yes, sir.
F of x4 is negative, right?
No, no. F of x4 is positive. F of x5 is negative. Coming.
Okay. What
Zeros.
about f of
I have, sir, I have got 2.0625. I have got the up to that I have
yeah,
got.
so so the point is here it is calculated between 2.125 and 2.0625. Okay. As I can see, the next one is 2.09375. So that means it is between 2.125 and 2.0625. Okay. So just check what is the value of f of x4. I believe it will come negative because f of x3 has come positive. Okay.
Um,
So that's why it is basically
mm,
calculating the midpoint of these two values. So 2.09375. So similarly, if you continue, the point is if you come up to x10 and x11, let's see 2.x10 and x11. Okay. What is the value x10? 2.094. X11 also 2.094. But after that, here it is 73, here it is 24. So now the point is how far we want to go. That's what it is telling you over here. That x11 minus x10 by x11, that is like 0.02%. So the change is very small. So now we can say, okay, the root is 2.094. The root is, the answer is 2.094. So this is how we calculate using bisection method. Okay.
sir, in exam it will ask up to which place we have to do, or we
No, no,
will
no,
go
no.
up to three place.
It will tell you what is the tolerance limit. or what is
Okay.
the approximation limit? Okay, so up to which decimal place you have to calculate? Let's say you're getting my point. Suppose I have to calculate correctly up to two decimal point, then I will try to match it up to third decimal and approximate up to second decimal. You getting my point? ଯଦି
Yes, sir.
successive root ର value match କରିଗଲା second place decimal ପର୍ଯ୍ୟନ୍ତ ତାହେଲେ ସେଇଟା root। ଯଦି ମତେ କୁହାଯାଇଛି ଯେ find the solution up to second place decimal place, ତାହେଲେ ମୁଁ ଦେଖିବି successive root ଧର ଯୋଉ x5 x6 କି x6 x7 ସେଇଟା ଯଦି second place of decimal ଯାଏ ମ୍ୟାଚ୍ କରି ଯାଉଛି ତାହେଲେ ଆମେ ସେଇ value ଟା ୟୁଜ୍ କରିବା, ସେଇଟା ହିଁ ତାର root। ଓକେ, କ୍ଲିୟର?
Yes, sir.
Okay, there are a few other problems you can look into that. Yeah. Let me come to the next method. Not iterative. Newton-Raphson. Yeah, let me come to Newton-Raphson. So Newton-Raphson method is also a similar method of finding solution to this polynomial equation or transcendental equation. Where the difference between bisection method, so one can ask why Newton-Raphson, why not bisection? Okay, so in that case, the answer is that Newton-Raphson, you might not have to that many number of iterations. That like as you can see in this example that we did, we have to go up to like x10 or x11 to get the answer. Whereas maybe in Newton-Raphson, it will get the answer in third or fourth step. So it is faster. So getting the solution is faster in Newton-Raphson method. Okay. So this method is generally used to improve the results obtained by one of the previous methods. Yes, let x naught be the approximate root of f of x is equal to 0. So here we do not take two values, you just guess. You just guess one value. That guess means it will not be the solution. Suppose x to the power 5 minus 1 plus 2x is equal to 0. I will put 1. 1 will not satisfy the answer. I know. But that is my quick guess. That is my guess. So that guess is x0. x0 be the approximate root of f of x is equal to 0. And so we have to find out the next one. Let x1 is equal to x0 plus h. X0 plus h, where h is a very small increment. Where h is a very small increment. If that is the case, we can just use the Taylor series expansion. I have written the Taylor series expansion in the last class. You can check that. Taylor series expansion. Huh? Maybe I can show you quickly. Um, just coming to Taylor
So,
series.
sir, what you have shown is Maclaurin series, na?
No. McLaren series is a special case of Taylor series.
Around zero.
McLaren series A equal to 0. Okay. That is,
But
if
that
you tell,
equation in Newton-Raphson method which you have shown there, you have taken a is equal to 0.
yes, exactly. For others, I'm just trying to show the, yeah, here. You know, you see, f of x is equal to f of a plus x minus a into f prime a. F prime a is df by dx into a. Df by dx at evaluated at a plus x minus a square by factorial to f double prime a. So it will continue up to nth term, and the nth term is basically it has taken as the remainder term. Okay, and if this is Taylor series, if a is equal to 0, then it reduces to Maclaurin series. All right, this is the what we have discussed last class. All right. Where were we? Here. Yeah. So this is what we have. F of x0 plus h f prime x0 plus h square by factorial 2 f double prime x0. So if we continue that with the Taylor series expansion and neglecting second and higher order derivative. What exactly is telling? Neglecting second and higher order derivative. This part. eh? This part we are neglecting. Why? Why exactly we are neglecting that part? We should not have neglected that one. Because h is very small. Here in our assumption, this whatever we have taken, x1 is equal to x0 plus h. So just a small increment. So if h is very small, h is a fraction, h square is even smaller quantity. So we can neglect that. So here comes the approximation. The approximation I was talking last class. Here it is not exact. We are leaving the higher order term. We are neglecting the higher order term, which is x1 will be equal to x1 will be equal to x0 minus f of x0 by f prime x0 f prime x0. Okay, and then we'll get the next value x1, and then we'll check what is the value of f of x1. If f of x1 is equal to 0, then we have the solution. If f of x1 is not equal to 0, if f of x1 is not equal to 0, what we will do? We will find out x2. We'll try to find out x2, and your x0 now becomes x1. जोटा x0 जोटा x1 थिला सेटा बडा x0 ହେଇଯିବ कारण फॉर्मूला रे जेतले पडिबो x2 will be equal to x1 minus f of x1 by f prime x1. ମୋ କଥା ବୁଝି होची?
Yes, sir.
Yes. And এই ভଳିଆ କରି କରି ଚାଲିବା କେତେ ପର୍ଯ୍ୟନ୍ତ ଯେତେ ପର୍ଯ୍ୟନ୍ତ f of x is equal to 0 বা जो सक्सेसिव x ର ଭ୍ୟାଲୁ ବାହାରିବ ସେଟା ମ୍ୟାଚ୍ ହେଇଯାଉଥିବ ଠିକ ଅଛି କ୍ଲିୟର
Yes. Yes, sir.
ଆମେ ବର୍ତ୍ତମାନ ସେଇ ଏକ୍ସାମ୍ପଲଟା ଆଉ ଥରେ କରିବା କୋଉଟା ଯୋଉଟା କରିଥିଲେ କୋଉଥିରେ ବାଇସେକ୍ସନ ରେ ନାଇଁ କି
Yes, sir.
just to check ବାଇସେକ୍ସନ ରେ ଯୋଉଟା କରିଥିଲେ ଆମେ କଣ କରିଥିଲେ let me come to that problem ହଁ କଣ ଥିଲା
Q minus
question
2x.
हाँ here x cube minus 2x minus 5 equal to 0 x cube minus 2x minus 5 is equal to so this is f of x cube minus 2x minus 5 tells you f of x so what is f prime x that will be 3x square minus 2 right 3x square minus
2.
2 ठीक था
Yes, sir.
हाँ so then what will be let's say you get a quick guess करो let's say the quick guess is x equal to 1 ताମାନେ x0 ଟା ହଉଛି 1 let's say quick guess is 1 1 ରେ ତ 0 ହଉନି but ଆମର ସେଟା guess okay ଯଦି ସେଟା ଆମର guess ତାହେଲେ next ଆମେ x1 ବାହାର କରିବା x1 କେମିତି ବାହାର କରିବା what is the formula for x1 x1 is equal to x0 minus f of x0 by f prime x0. ठीक था?
Yes, sir.
Coming to the formula. Coming to the formula. ଏଥିରେ ଏଇ ଫର୍ମୁଲାଟା ଖାଲି ମନେ ରଖିବାର ଅଛି। x1 is equal to x0 minus f of x0 by f prime x0. ତାହେଲେ ମୋର x0 ଟା ହଉଛି ଫାର୍ଷ୍ଟ ଗେସ୍ ଟା ହଉଛି 1. So that will be 1 minus f of 1 by f prime 1. f prime 1 ମାନେ f prime ଟାର ଭ୍ୟାଲୁ କେତେ? 3x square minus 2. x ଜାଗାରେ 1 ପକେଇବି। ତାହେଲେ evaluate. What is the value of x1? Use your calculator and evaluate. ବୁଝି ହଉଛି କେମିତି କରିବା? All of you are getting it or not?
Sir, what we will put in? Suppose we have put one. So one minus.
Yeah. Let me write down. Let me write down. Sorry. Let me write down. So what exactly? So my x1 will be equal to x0 minus f of
Of x
x0
divided by f
by
dash
f
x0.
prime x. Right? What is my f of x? It is equal to x cube minus 2x. What is it? X cube minus
Minus 5.
2x
Minus 5.
minus 5. And my f prime x is equal to
3x minus 2.
3x square minus
Sir,
2.
3x minus
Now I have taken x0 is equal to 1, let's say. Alright. So my x1 will be equal to x0 minus f of oh, sorry, f of x0 by f prime x0. So that will be equal to 1 minus 1 minus f of x0. f of x0 ର value କେତେ? f of 1 ର value କେତେ? If I substitute 1 in this expression, it will be 1 cube minus 2 into 1 minus 5. So 1 minus 2 minus 5 minus 1 minus 7. So that is equal to minus 6, right?
Yes, sir.
That is equal to minus 6. All right. That is equal to minus 6 divided by. If I substitute 1 in the f prime x, substitute kole kete milbo? 3
1.
into 1 square. So that is 1. 3
3
minus
minus
2 is
2.
1.
1.
So that means my x1 is equal to 1 plus 6, which is basically equal to 7. All right. Which is equal to 7. Now what I will do? I will try to find out what is the value of f of 7. So next part is I will find out what is value of f of 7 and what is the value of f prime 7. Find that value and then find out what is x2. x2 will be equal to what? x1 minus x1 minus f of x1 f of x1 divided by f prime x1. Getting my point? Tell me what is the value of x2 you are getting? x1 ଜାଗାରେ 7 put କରିବ କେତେ ମିଳିବ ତାର?
Sir, in this way, we will not go far away
No, no,
from
no,
the.
no. Just work it out. Just work it out. Don't take it that we are going up to 7. That's why we will not get. Okay.
Okay, sir.
Just try to find the answer of x2.
Hello.
Hello?
Sir, we are getting 4.7655 like
Four
that.
4.7655, right?
Yes, sir.
Yeah. So now let us try to find out what is x3. X3 will be what? 4.7655 minus similar way, right?
F of
That will be
4.7655 divided by A prime 4.7655
yeah.
like.
Yes,
Okay.
yes, yes, yes. Try to find the
So this will require a scientific calculator because small calculator we am getting. Um,
yeah, this is just a general example. I mean, in exam they will be giving much easier example. Why I'm using this example? We have used that in bisection. That's why I'm asking you to work it out this way.
sir, like
Okay.
graduation, the scientific calculator will be allowed, no?
Yes.
Where we can put the values.
Yeah. If it is required, it will be allowed, right? If it is required to work out the problem, then it will be allowed. It's not an issue. Okay.
Because if transcendental equations will be given, we cannot do with this simple calculator also.
Yes.
Uh,
Yes. 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 How much we are getting? 3.3487. Are you getting something?
Sir, my calculator is losing the track again and again because I have to write the number and again have to put it there. This is a simple calculator and it's making mistake.
Okay.
I-
Okay. So I just worked it out. So X3 you will be getting 3.3487. Okay. X3 you will be getting 3.3487. X4 you are getting 2.5316. Okay. X4 you are
okay.
getting 3.2.5416. Okay. And
Yes,
I
sir.
believe if you go up to X5 and X6, X6 it will converge. X6 it will converge to the same value we got in bisection. Whereas in bisection we went up to X11. Okay. Because when I mean, since we are doing it using calculator by our own, so it is taking time. But if you just use a Excel sheet or a computer, the computer will do it in seconds, right? The computer will do it in seconds.
Sir,
So that's why
this is
computational
computer
physics.
finds the answer. Sir, is this the way
Yes.
computer finds answer? In means modern day computer find answer like this only.
Yeah, yeah. We actually, if we write a program, if we write a program, then computer will do it these steps actually. It is not visible to us.
Okay, means
But
backend
uh,
goes like that only.
yeah,
It,
backend they actually use Newton-Raphson method. It's a famous
oh,
method which is being used by. So if you give some equation, solve this equation, computer will give you an answer where the decimal point up to maybe 15, 16 decimal digits, right?
because iteration is
So
not
so
a
it
problem for
so
computer. So it can do
yes,
again and
iteration is
again.
not a problem for computer. It can do up to, so in general the tolerance limit in computers is up to 10th decimal place. Okay. So it will
Okay.
calculate accurately up to 10th decimal place. So that will not be a problem for, but I mean, here the comparison is whether you are using bisection or Newton-Raphson. Bisection, you will get the answer, but it will take many number of steps. Whereas if you take Newton-Raphson, it is taking less number of steps. Second thing is bisection, you have to kind of hover around which way I should go. Every time you have to see what is the whether the product is positive or negative, positive or negative. If any stage you make a mistake, then you will be moving on the other way, right? But in Newton Raphson, there is no other way. That is just you find out what is x3, then you use in place of x2 you use x3. You find x4, so for x4 instead of x2 you use x3. So just you keep on doing. You are replacing the previous number by the new number and doing the same thing. X minus f of x by f prime x, right? That is the formula you are using. And then finally you will get the answer. All right. Yeah. Yeah. I believe in exam they will ask smaller ones. As you are right. If you are given a transcendental equation like this one, x sin x plus cos x equal to 0, then you need scientific calculator. But for computer, it is very super easy. The computer will just use this kind of table, uh, and then you just. I believe in the lab they will do it for you. It is there. The computation physics lab, these methods are there. All right. All right. I will take 5 minutes break here, and then when I come back, I will try to see the other numerical techniques that we'll be discussing. Okay.
Okay, sir.
Okay, we'll start the other techniques. This book by S.S. Sastry will be very much useful. Other than your materials, I suggest all of you this book, Numerical Methods by S.S. Sastry, will be very much useful. My screen is visible, right?
Yes, sir.
Yeah. We'll discuss something called numerical differentiation and integration. I guess, I mean, in +2 level, all of you have done this differentiation and integration. Most of the time, differentiation using formula, right? And integration is also again by formula only. It's kind of inverse of differentiation. But you might have, I mean, already realized that uh, it is not so easy to integrate functions. Maybe differentiation is somewhat tackable, but integration is not that easy because we do not get exact functions. So what we do, you at worst case, we just integrate by parts and keep on doing that. But that complicates actually because integration of integration, those terms keep on coming. And for that, it is using a computer, we can do integration and differentiation. But then that differentiation or integration is more approximate methods, not exact methods. Okay, that's what it is telling you that uh, interpolation is, I have explained interpolation last class. So it is bit like you want to find out in between points. And here differentiation is basically you have to find out the slope dy by dx, d square y by dx square. Yeah. So the general method for deriving the numerical differentiation formula is to differentiate the interpolating polynomial. Okay. And corresponding to each of these formulae derived, we have a new formula for the derivative. And one such method is Newton's forward difference formula. Newton's forward difference formula. Okay. Let us first examine the formula. Uh, and coming to this question, how it should be like. So you are given with a table. What you are given? You are given with a table. In the table, what is there? You are given with a table, and in the table, it is the x value, and y value. X1, you have some certain y value. X1.2, you have certain y value. X1.4, you have certain y value. X1.6, you have certain y value. X1.8, you have certain y value. X2, you have certain y value. X2.2, you have certain y value. So what is there? There are certain x values and corresponding y values. You are given. And now it is asking you, find out what is the value of dy by dx or d square y by dx square for x equal to 1.2. Another way of asking the same question is also giving y is equal to f of x. ଆମେ ଯେତେବେଳେ ସବୁ କରି ଆସିଛୁ ଆଗରୁ ସେଥିରେ ଆମକୁ ଦିଆ ହେଇଥାଏ କ'ଣ y is equal to f of x. ଯଦି y is equal to f of x ଦିଆ ହେଇଛି ତାହେଲେ ବି ଆମେ ଏଇଭଳିଆ ଟେବୁଲଟେ ଜେନେରେଟ କରିପାରିବା ନାଇଁ କି ଯଦି ସପୋଜ କୁହାଗଲା y is equal to x square তাহলে x1 ବେଳେ y1, x2 ବେଳେ y4, x3 ବେଳେ y9. So you can generate this table. Or in general ଯଦି ଆମକୁ ଫଙ୍କସନ ଟା ଦିଆ ହେଇନି ତାହେଲେ କୋଉ ଫର୍ମରେ ଦିଆ ହେଇଥିବ ଆମକୁ ଏଇ ଡାଟା ପଏଣ୍ଟ ଫର୍ମରେ xy ଫର୍ମରେ ଦିଆ ହେଇଥିବ ସେଇଥିରୁ ଆମକୁ କୁହାଯାଉଛି କ'ଣ obtain the value of dy by dx and d square y by dx square. Derivative and double derivative. Okay. So what you have to do is basically you have to find the difference table. You have to find the difference table. Difference table ता केमती बाहर करिवो? Look at here. This column is given. This column is also given. Where? Here. Here it is given. Here it is given. Okay. Now, what is delta? What is delta? What is delta? It is the difference. What is this delta? It is the difference. Okay. Difference between what and what? Between this one, 2.7183, and this one. Okay. You can check that. All right. How much you are getting? 0.6018, right? Isn't it? So if you this number is basically difference between this one and this one. This number is difference between this one. What is delta? What is delta? Delta square. Delta square means delta of delta. Delta square is delta of delta. Okay. So you want to find this one. So take the difference between this one and this one. All right. You want to find this one. So you have to take difference between this one and this one. So this is how we find out delta square. We find out delta cube, delta 4, delta 5, and finally delta 6. Finally delta 6. Okay. Now, what is the formula? What is the formula that we will be using for finding the derivative? Okay. So let us come to just 1 second. So we'll be using this formula. This is the exact formula. Y is equal to y0 plus u delta y0, u into u minus 1 by factorial 2. Okay. And you can see, if once we do the example, you will see. So here, x0 is 1.2, y0 is 3.3201. H is the step in x. Step in x is 1.02. So the step is 0.2. 1.2, 1.4. Step is 0.2. 1.4, 1.6. Step is 0.2. If we substitute that, in this one, so what you will get? dy by dx, dy by dx. Hmm? This one. You can see this problem. dy by dx at x equal to 0 is equal to 1 by h. H is known, 0.2. Delta y0. So first order delta. Delta is known, y0 is known. Next one is delta square into y0 divided by 2. Next one, delta cube y0 by 3. Next one, minus 1 by 4, delta 4 by y0. And you will say, sir, how far I should go? How far I should go? Because in our example, how far you can go? You can go up to delta 6. That's all. You can go up to delta 6. Hmm. So if you can see that, if you can substitute that, you'll see. All right. So x equal to 1.2, dy by dx at x equal to 1.2. Dy by dx at x equal to 1.2, you get this much. So d square y by dx square, again, you get this value. So this is how, by Newton's forward difference, you can get the derivative. You can get the derivative. Okay. Similar formula is also there for Newton's backward difference. Okay, this formula is for backward difference. dy by dx x equal to xn. Hmm? X equal to right. Newton's backward. This formula x equal to xn. Okay. Okay. So there are various other methods, but this Newton's difference and backward difference, these methods are quite popular. Okay. Next one would be numerical integration. Numerical integration. So can anyone tell me what do you mean by integration? Integration का मतलब क्या है? What is the meaning?
Sir, geometrical meaning.
Yes.
If we will draw a curve for the that equation,
Yes.
then the area under the curves give us the value of integration.
Yes. So let me try to draw over here. So let's say okay, let's say I have a curve like this. Okay. This is y, this is x, right? And this is f of x. And if I want to integrate between a and b, so this is f of x dx integration from a to b. So that is nothing but finding the area of this region, right? And how do you find the area? There are different ways. There are different ways. So what we do in numerical integration, we try to divide this region into strips, into strips. Okay. So we want to divide this area into strips. So each strip, so approximately each strip will look somewhat like a trapezium. Each strip will somewhat look like a trapezium. Each strip. All right. And from there the name comes trapezoidal. So what is the area of a trapezium? From high school we know what is the area of a trapezium. Trapezium is like two parallel sides. It's a quadrilateral. जो quadrilateral रो दीटा parallel sides ଥାଏ ଆଉ ଆର ଦିଟା parallel ନୁହେଁ ତାର ଏରିଆ କେମିତି ବାହାର କରାହବ trapezium ର trapezium ର ଏରିଆ
Hello.
ମନେ ଅଛି ନା
Hello.
yes yes yes
Oh. Sir, half into height into sum of the non-parallel sides.
half
There is
into height into sum of parallel sides not
parallel.
non-parallel
Oh, sorry,
sum of
sorry.
parallel sides
Parallel
yes
sides.
sum of parallel sides so half into sum of parallel sides sum of parallel sides into half into the height into the height. So in this case, in particularly this case, my left hand side is basically some y1, right? Y1 and this is y2 and this is h. Okay. So this will be y1 plus y2 hmm, divided by sorry half into half into h. right? Now, what is y1 and what is y2? This is basically your fa plus fb, isn't it? Fa plus fb. So if I take my this h to be very very small, in general it will not be a trapezium. But if h becomes very very small, if h becomes very very small, then this will look like a trapezium. And then the starting point on the left will be A, and next second point will be, so this will be the starting point will be A, and this will be A plus H. So next one will be A plus H and A plus 2H. The next one will be A plus 2H, A plus 3H. And at each A value, we can find out what is the value of f of x. So that is like f of A plus H, f of A plus 2H, like that only. Okay. So that is what is being done in trapezoidal rule. So y naught plus half delta into y naught. If you use that, this is what you are getting h by 2. Same formula h by 2 y0 plus y1. H by 2 y0 plus y1. Y1 plus y2. Y2 plus y3. It will keep on doing that, right? So finally, what you will get? Finally, if you add all these expressions, it is the thing. Combining all these expressions, the rule would be h by 2 y0 plus. So first and last will be single, because see what exactly you are doing. Y first one is y0 plus y1. Next one is y1 plus y2. Next one is y2 plus y3. So only the first one left side will be single y0. Next one will be y1 plus y1, y2 plus y2, y3 plus y3, like that only. If you write that, so then it will be y0 plus twice of y1 plus y2 plus up to yn minus 1, and the final one would be yn. So this is something called the trapezoidal rule, and it can easily, we can easily from the mm, data we can easily find out what is the integration, because what is given, y is equal to f of x. And if I produce, so the strategy is, let's say you are given an integration. Suppose I am giving an example. All of you should write it down in your notebook. Okay. Suppose I am given with an integration x square dx integration from 2 to 4. All of us know what is the value, but numerically how to do using trapezoidal rule. So my f of x is equal to x square. F of x is equal to x square. So what is my a? A is equal to 2. A is equal to 2. All right. A is equal to 2 and B is equal to 4. Now what I want to do? I want to divide this A between A and B 10 strips. 10 strip means, so 4 minus 2 by 10. So that will be equal to how much? 2 by 10, which is equal to 0.2. So my point should be 2, 2.2, 2.4, 2.6, 2.8, 2.10, or 3. Huh? 3.0. So 3.0, 3.2, 3.4, 3.6, like that up to 4. Now for each x value, I can find out what is f of 2. F of 2 is equal to x square. I have taken x square, right? So if it is x square, f of 2 will be equal to how much? 4. F of 2.2. What is the square of 2.2? 2.2 square कितने?
4.84.
4.84. Yes. So f of 2.2 is 4.84. Okay. What is square of 2.4? F of 2.4 would be 5.76. 5.76. So similarly, we can find out what is the square of 2.6, 2.8. So the point is, I can find out what is F2, what is F2.2, what is F2.4, up to what is F4. F4 is equal to 16, right? And the integration value would be what? The integration value would be h by 2. Here, what is the value of h? H is equal to 0.2. So the integral value is h by 2 into f first point, fa, or if you call it 1, f1 plus twice f2
Sir, are
twice
you
f3.
writing on the board?
No, no, I'm not writing. I'm just telling you.
Okay,
I'm
okay,
not writing
okay,
anything. Yeah,
okay.
this is simple. This is just simple. I'm following that formula. Right? I'm just following the formula. I'm not writing it.
Okay, sir. Okay, sir.
Yeah. The point is, my point is, if you are given with, if you are given with a function, you can find out, uh, let's say 10, 20, or n number of data for x points. Once you know the x points, you can find out the y points. If you are given with the starting point of x, ending point of x, then you divide it into maybe let's say 10 steps or 20 steps or 100 steps. Then you know what is the step length and what are the points. Once you know the points like x0, x1, x2 up to xn, you can find out using f of x what is f of x1 or f of x0, f of x1, f of x2, like that. So those are called f1, f2, f3. Okay. And now using this formula 6.33 over here, using this formula 6.33 over here, you can find out what is the value of the integral. Let us work out one problem. Let me see if they have it. No, they don't have it here. I think after Simpson one third. Let me see. Yeah, can you work out this example 6.8 using that trapezoidal rule? My screen is visible, right?
Yes, sir.
Yeah. So could you quickly use that formula and try to see what is the area or what is the integration from for 7.47 to 7.52. The values are given actually. You don't have to calculate much. You just have to add numbers. So can you tell me what is that answer? Are you able to work it out? This is the integration we have to do, right? From f of x from 7.47 to 7.52. So what are the steps? Steps is h is 0.01, right? The h is 7.47, 7.48, 7.49. X steps are 0.01. So your h value is 0.01, and you are given with the values f1, f2, f3 up to f6. So what you will do? You start with f1 and the final one will be f6, but in between you will multiply 2. In between you will multiply 2. Add them and get the answer. Are you getting it?
Sir,
Are you getting? Are you following what I am telling? Let me explain again. You are given with,
sir, yes, sir, we got. I got, sir.
you got,
0.09965.
yeah. This is how we actually find out numerical integration. Okay. This is one way. And the faster way, there is also another faster way. This is one technique, trapezoidal. Another is called Simpson 1/3 and Simpson 3/8. Okay. So only the difference is the formula. The difference is the formula. Okay. Let me come to that formula. Yeah. So in Newton's one third, this is the formula you will be using. This is the formula you will be using. So what is the y0 plus 4 times y1, y3, y5? So all odd turns into 4, all even turns into 2, then the first term and the last term. This is slightly bit more accurate because what exactly is doing, instead of taking end to end points, it is taking the midpoints. It is taking the midpoints. So similarly, if you use Simpson's 3/8 rule, Simpson's 3/8 rule, so then you will be using this formula. You'll be using this formula. Okay. So there are a few other formulas as well. Like this, we can find out what is the value of the integration. So if one integration cannot be done using normal analytical techniques or by integration by parts, then the last method that we use is by approximation method such as Simpson's 1/3 or Simpson's 3/8 rule to calculate the integration. Okay. Any question?
So these are exactly similar, only formula is different.
The formula
We
is
have to
different
put
and
this formula.
slightly more accurate. Slightly more accurate. Slightly more accurate. What exactly is happening? Let me tell you. Like if you have a curve, so let me draw it. If you have a curve like this, so in trapezoidal, it is just approximating it as a straight line, whereas in Simpson's 1/3, it is taking another point over here. So it is taking like this. So in between there is a point. So it is more accurately calculating the area. 3/8 is even like it is taking here. It is taking 2 point. In trapezoidal, it is 2 point. First point and end point. And Simpsons 1/3, there is 3 point. And then Simpsons 3/8, there are 4 points. In between, there are two more points. So which gives more accurate integration result. Okay. Yeah, these are few of the techniques. I mean, I would personally suggest all of you to yeah, go through the text link they have provided in the e-GAN post pages. But personally, this SS Sastri, numerical methods by SS Sastri, that will be very much useful uh, and handy as well in understanding these techniques. And there are numerous examples which you can understand from the example as well. You can understand from the example as well. Okay, so the session is kind of open for question. If you have any doubts, anything, you can ask. And there are a few other techniques that I think we can read, and there is not much difficulty in that. It's just formula based. Uh, so you have to kind of somehow kind of remember the formula by solving numerical problems. Any question? Any question? No. So then I just put the last one as this book. Uh, Try to get a copy of this book somehow. That will be useful. Okay. Methods of numerical analysis.
Please provide its PDF format book.
Yeah, check with the center if there are some other materials as well. Yeah. Yeah, this book is also very cheap actually. I mean, much cheaper than I think 200-300 rupees. I think. Yeah, this is other than what materials they have so provided. The material is very good enough, and sufficient to understand, but this will be more helpful.
So can you share its PDF format?
Not at this platform. Let me see if I can, but I have to check it because maybe some copyright will come. I don't know. Let me see and then yeah, if possible, I'll do that. All right. Yeah, you can search it in the web also. I have searched it
Okay.
in the web.
It is 386 rupees in Amazon, sir.
Yeah, yeah. So it's very cheap actually, but it is very useful. It's an Indian author who has written it, so it is not very useful actually for this particular course. You will understand much better once you solve few examples from this course. Yeah, if there is no more questions, I will possibly stop it here. And yeah, uh, good luck with your
So
studies.
next day, which topic you will deal?
Well, at this point, this will be my last class. Next, I don't know. Whatever they assign to me. Yeah, because your next one is like I think. What is the next course? Next course is reactor physics or something like that. No?
Oh,
Yeah, that is I think Gauri will teach. Yeah, I don't know. Other courses I don't remember. They have given me a list, but I don't remember. This is my last class for this semester.
last
If
class
they
of
assign,
MPH-14, computational physics.
yeah, yes, they have given only two classes or two double classes.
No. we have some question from it's 5.7 unit uh, 4 on block 2 and uh, block 2. But
Which one? Which one? Could you repeat again?
few topics of block 2. But I have at this time I have no PDF material, so it is difficult to ask.
Of this paper, computational physics. Which paper you are
I
talking?
have I have no PDF.
Of which
So,
paper?
sir, MPH 14 block 2. I
In
have
page 14.
at this moment block 1 PDF available, but block 2 is not available right now.
Okay, just hold on 1 second.
Today you deal uh, numerical interpolation topic. And
Yeah, you were present only last class. Yesterday you were here. You were present.
yesterday not present. Today I have continued
Yeah.
watching.
So actually, just talk to your friends. I have given a link. I have given a link. I have
Yes, sir.
given a link in the chat box yesterday. Okay. If you go to that
Okay.
link, the whole book of Cow, Numerical Methods and Applications by Cow, that book link I have given. Okay. So there you will find all the uh, description. Just
Sir,
talk to
uh,
one of your friend. Yesterday I had given that link in the chat.
okay.
Yeah.
Thank you, sir.
And of course you can use try to find this book. This book will also be very much helpful other than the Cow book. Okay.
Sir, I will purchase, but it is your last class. Then if today I will ordered, then it will receive 4 or 5 days after. Uh,
You can you may get it in the local bookstore. It is widely used book, I think, by mathematics students and BSc mathematics. They use this book. So I believe in any local market, oh, you will find it. I mean, if you are thinking that it will take longer time, why I'm suggesting there are many numerical methods books, but why I'm suggesting this because this book is written in a language which an normal average student can understand. That's why I'm describing this one. Very lucid language, easily understandable language. It is written.
or sir, the material provided by IGNOU is it's a step is short or it if the if we uh, put in examinations copy the step which is short, then we then the number deducted.
No, well, see, in an exam, if it is asked to derive something, then it is expected that you derive all the steps. Let me put it that way. In the books, in the material, there might be they might have skipped some steps, but when you write in the exam, it is expected that you derive all the steps or you write all the steps. So during
And sir,
study, if
one more
you,
question. In each step, we hello sir. In each
yeah,
step,
your
we
voice,
put error. Hello sir. Hello sir.
yeah, your voice is kind of
Hello.
not clear. Could you repeat?
Okay, okay sir. I am repeating. Hello sir.
Yes.
In each step, its error or also show as you told in bisection. rule
Yes,
or Newton-Raphson method.
yes.
In each iteration, its error also shown in examination or the last
No,
step
well, it is it
shown.
is it is not necessary to write error in each step. Only when, as I said,
Yes, sir.
let's say in bisection, you are expected to find
Okay.
out the answer up to second decimal place. Then when you see that the consecutive x points, it is matching up to second decimal point, then it is the answer and the
Okay.
error is the difference between those two x values. Okay.
Okay, sir. And sir, further your class will be scheduled on any
Yeah,
uh, course.
that you can check with the study center. Huh? That you can check with the study center.
Okay.
If they sign, then I have no problem. Okay.
Okay. Thank you, sir.
Okay. Good luck, everyone.
Thank you.